Hello students and welcome to this very important lesson. Once again, we are going to look at the second topic of calculus, that is integration. This is after looking at differentiation in two lessons. So today, we want to navigate through integration in a very magnetic way. Now, dear students, in our last two lessons in differentiation, we had looked at the application of differentiation in kinematic and so on. So today in this lesson, we will look at integration. Now, before we begin, subscribe, comment, like, and share. Now, students, we need to begin by understanding the term integration. So, what is integration? So here, we say that integration, it is the reverse of differentiation. So we say that integration is the reverse of differentiation. And what do we say about differentiation? We say differentiation is the process of obtaining a derivative function or a gradient function from any given equation or curve. Now, what about integration now? So about integration, when we are given the derivative function, we obtain what we call the equation or the curve. So we can also say that it is the process of obtaining a function from a gradient function stroke derivative. Now, students, if you understood well about differentiation, then integration will become very simple, because anything that we do with integration, we do with the differentiation, is opposite when it comes to differentiation. Now, we will look at how to integrate. We had looked at how to differentiate. So about differentiation, we said number one, we said we bring the power down. Say that we bring the power down. Then we say reduce the power by 1. That's how to differentiate. Now, what about integration? So about integration, we say the first thing is increase the power by 1. Increase the power by 1. Then number 2, divide by the new power. Those are very, very important things to understand. We increase the power by 1, then we divide by the new power given an equation. So we say that given an equation to integrate, we increase the power by 1, then we divide by the new power. Then we add the constant which is C. Now, students, let us do some examples. Examples. We have part A, maybe we have 3x squared. So given this, to integrate, the first thing is to increase the power by 1. So it becomes 3x 2 plus 1. Then we divide by the new power. So the new power is now 3. So this means that after integration, we get as 3x cubed over 3. So therefore, the answer is x cubed. That's how we integrate part 2. But now, after integration, it becomes a curve. Therefore, we say that y equal to this. Remember we said we add the constant c. So you need also to add the constant c. And this constant is unknown. We will reach a point whereby we will be required to get the value of c. Given x and y. Now students, let us do the other example. Part C, part B, given 5x cubed minus 2x plus 4. What is important here is to understand that we increase the power by 1, then we divide by the new power. That's the key point. Then we add the constant c. Now here, dy dx is given by 5x cubed minus 2x plus 4 dx. Now when we integrate, we increase the power by 1. Here is 5x increased by 1 over the new power 4 minus 2x. It becomes 2x squared over 2. Then plus 4x over 1 plus the constant c. This becomes our equation. So given that, it becomes 5 over 4x raised to 4 minus x squared plus 4x plus c. But remember, this now becomes a curve. They will say y equal to. So this is what we call integration. That's what we call integration. Now students, let us move on. Given any other example in part C, that x raised to negative 2 plus 5x. To do this, we say we increase the power by 1, divide by the new power. So given 3x negative 2 plus 1 over negative 2 plus 1 plus 5x 1 plus 1 over 2. So here is y equal to this. Then we add the constant c. So this one now becomes negative 2 plus 1 is negative 1. So it is 3x raised to negative 1 over negative 1 plus, here we have 5x squared over 2 plus c. So y equal to, remember these negatives, when we divide it comes here. So y equal to negative 3x by negative 1 plus 5 over 2 x squared plus c. So this becomes our equation. So students, what is very important up to this point is to know how to integrate. And we have already looked at several examples on how we can integrate. So to integrate, the very important thing is to increase the power by 1. Then after increasing the power, we divide by the new power. Then after dividing by the new power, we add the constant c. Now students, in differentiation, we say that given a curve, we integrate, we differentiate to get the gradient function. Here we can be given a gradient function and be asked to get the curve. Now for example, let us do a question. Example, say that the gradient function of an equation is 3x squared plus 10 passing through point, we can say 4 and 5. They say full stop, find the equation to the normal. Now students, that is You can say find the equation, not to the normal, just find the equation. When we talk about to the normal, this is about finding the equation. Now, if asked to find the equation, here is the gradient function. We say that when we integrate the gradient function, what we get is the curve. So we say that solution dy dx of this curve, that is x squared plus 10, will be able to give you the curve, that is y equal to, when we integrate it becomes 3x cubed over 3 plus 10x over 1 plus c. So the curve is given like that. Now, have y equal to x cubed plus 10x plus c. Remember, we need to find the value of c, students, which is our constant. Now, remember, we are given the point through which this curve passes through, and it is in coordinate form. It is in the form of x and y. Therefore, for us to get the value of c, we replace where we have x and y, so that we can be able to find the value of c, students. Therefore, we replace, this is y is 5, equal to x is 4 raised to 3, plus 10, we have 4, plus c. Now, given this, 4 raised to 3, it is just like 4 times 4 times 4. And this gives you 16 times 4, you get 24, carry 2, you get 64. So here we have 5 equal to 64 plus 40 plus c, plus 40 plus c. So we need to get the value of c at that point. So the value of c will become very simple. We say that 5 equal to 64 plus 40 plus c. So this is 5 equal to 104 plus c. So it means that c equal to, remember this one comes on the other side, so it becomes 5 minus 104. So c equal to negative 99. That's the value of c, students. So given the value of c, we go back to our equation and replace the value of c. This is our equation. So when we replace the value of c, it becomes y equal to x cubed plus 10x minus 99. So this is how we find the equation given the gradient function. So dear students, let us be able to identify how to do these questions. Given the gradient or the derivative function and the point where it passes through, you can be able to find the constant and replace your equation so that you get the value of c. Now students, if you want to prove that integration is the opposite of differentiation, you can, when you integrate this, you will get to this function. So for example, if we try to integrate, the law of to differentiate, the law of differentiation says we bring the power down, we reduce the power by 1. So it becomes 3x squared plus 10. As you can see, you find out that it is the reverse of differentiation. So whatever we do in differentiation, we reverse and we do in integration. So let us move on, students, to another basic important concept as far as integration is concerned. Now, we need to know the types of integration. We have two types of integration at this context. We have two types of integrals. We have definite integral and indefinite integral. So we have types of integration. We will begin. We have two of them. We have definite, then we have indefinite. Definite integral. When we talk about definite integral, it's a type of integral that has limits. We say has limits. And this is has no limits. Has no limits. When we talk about limits, for example, the symbol for integration is given like this. It is just like that. Then limits, for example, 0 to 3. Then you have 4x squared plus 2x plus 3. So if you integrate with the given limits, that's what we call a definite integral. But if we don't have the limits, for example, you integrate without limits, 4x squared plus 2x plus 3. This type of integral is called an indefinite integral. So let us be able to identify those types of integrals that we have. Now, in our exams, in most cases we are given equations. We want to do some example, like they can tell you to evaluate. Then they give you a question like 0 to 1, they have the limits. Then have x raised to 4 minus 5 dx. They say evaluate. So even this, remember you have the limits, students. So you integrate from 0 to 1. There, the first thing we integrate. So when we integrate, the law of integration says what? We increase the power. We increase the power by 1. We divide by the new power, and therefore this one we do it like this. This one becomes x raised to 5 over 5 minus 5x over 1 plus c. We integrate from 0 to 1. Now this is very simple, students. Given this, we can be able to find, say that we replace the value of x. We begin by 1, then we finalize by 0. So this one is 1 raised to 5 over 5 minus 5 raised to 1 into 1 over 1 plus c. Then we subtract by the value of 0. Say that 0 raised to 5 over 1 over 5 minus 5 into 0 over 1 plus c. Students, that's how we arrange that question. Given the limits, we begin with the largest limit, then we move to the smallest limit. Now after reaching that point, you can be able to finish up that question. Very, very important. Now there, we say that it's 1 over 5 minus 5 plus c minus this we have is 0 minus 0 plus c. So we find out that we have 1 over 5 minus 5 plus c. Then we have here is minus. So remember the value of c and the value of c cancels. So we remain with 1 over 5 minus 5, then minus 0. So there, when we punch on our calculators, we will be able to find the answer of this, that is 1 over 5 minus 5 over 1. So we can say the LCM is 5. 5 into 5 is 1, minus 5 is 5, times 5 is 25. So we get negative 24 over 5. So your answer is negative 24 over 5. Square units. Square units. So students, given this question, you neglect the negative to remain the positive answer. Then you have 24 over 5 square units. This is how we do it. The first very important step is to know how to integrate. Then know how to replace these limits. From which limit to which limit. That's very important. Now, that's all about definite and indefinite integrals. Okay, students, welcome back. Now we move on by looking at another subtopic, that is finding area by integration. Finding area by integration. So students, we can use integration to find the area, and this gives the exact area. So say that integration is the one that gives the exact area. We have other methods of finding area like use of mid-ordinate rule and use of trapezoidal rule. But this integration is the one which gives the exact area. Now we can find area, number one, under the curve, under the curve, the curve, the curve. Number two, we can find area between a line and a curve. Between a line and a curve. Number three, we can find area between a curve and a curve. Between a curve and a curve. So we can use integration to find area by these three ways. So in an example, you can bring a question attaching a line and a curve for you to find area by integration. Now students, let us begin by looking at under the curve, area under the curve by integration. Now given, for example, given like this, then we have a curve like this is 9, this is 1, then this curve is y equal to x squared minus 10x. Then this is shaded. And ask you to find the area of the shaded region. This is the area under the curve. This is our curve. So area covered by this curve, we can find its area by integrating this equation. So when you integrate this equation, we get the from which limit? From 1 to 9. Now students, we integrate from 1 to 9. This curve, that is x squared minus 10x dx. That's how we integrate that. So when we integrate that curve, we get the area. Now, when we integrate, the law of integration, increase the power by 1, divide by the new power. Therefore, we say x cubed over 3 minus 10x squared over 2 plus c. We integrate from 1 to 9. Now, students, when we do this, we find out that we replace by 9, that is 9 cubed over 3 minus is 5 into 9 squared plus c. This one we minus by, that is 1 cubed over 3 minus 5 into 1 squared plus c. So we calculate this one, then we subtract this one. Now students, let us punch on our calculators. We have 9 raised to 3, divide by 3, then minus 5 into 9 squared. So here we get negative 162 plus c minus minus 4 2 over 3. So when we have negative 162 minus 4 number 2 over 3. So we find out that you get 157 and a third square units. So the measurement here we use square units. 157. So when we integrate from the limit 1 to 9, when we get a negative answer, it is because it is under the axis. So because it's under the axis, the answer we get, we neglect the negative. So area cannot be negative. Therefore, when we neglect the negative, it is 157 and a third square units. That is the correct answer. That is finding the area under the curve. What is very important is to know how to integrate. Because we move the limits. From which limit to which limit? From 1 to 9. That is the limits that we are using to integrate. Very, very important. Now let us also move on and look at the area between a line and a curve. Between a line and a curve. So area between a line and a curve, we can be given an example like, for example, is when they tell you to have a curve, then we have a line, then is the shaded region. They ask you to find the area of the shaded region by use of integration. Remember the equation of the curve is y equal to 9x minus x squared. Then the outcome of the line is y equal to x. Then remember, you've not been given the limits, but it is beginning from the 0. So limits begin from the 0 up to where here we don't have the last limit. So students, here it is very, very important for us to be able to understand how to get the limit and integrate. So area of the curve, the equation of the curve is y 9x minus x squared. The equation of the line is y equal to x. Unapopewa hii mbili, we have y equal to 9x minus x squared, alafu hii ingine ni y equal to x. Kwa hivyo, the value of y equal to this and y equal to this. So this means that y equal to y. That's very, very important. Now, therefore we say 9x minus x squared. Y inatoshana na y. Hiyo inamaanisha ya kwamba the values of y at this point are equal to the values of y at this point. So we say y equal to y, and therefore this value is equal to this value. So it's equal to x. So after reaching at that point, we collect the like terms. Then we say that this come on the other side. We say 9x minus x equal to x squared. So here is 8x equal to x squared. So we say over x over x. So we say x1 inaisha na x moja, ex moja inaisha na x. So x inabaki hapo equal to 8. So the value of x at this point is 8. Now the limits, now you have got the limits of integration. So it means you will integrate from 0 to 8. Dear students, that's how we get the limits of integration. To get the limits of integration, you first of all equate. In a question, you can be given the limit. In another question, they can not deny you the limits so that you'll be able to get more marks. Now, students, after getting the limit, you now integrate each equation separately. For example, we integrate from 0 to 8, we begin with that one, x. So when we integrate this, it will be, we increase the power by 1, x squared over 2 plus c. Integrate from 0 to 8. So this means that when we integrate this, it will be now, we begin with the 8 squared over 2 plus c minus 8. We have 8, now we replace with 0, that is 0 squared over 2 plus c. So remember this one becomes a 0, c and c will cancel. So we have 64 over 2, it is giving us 32 square units. So students, when we do this, we get the area enclosed by the line and the area enclosed by the curve. Then after that, we subtract the two areas. So after we subtract the two areas, what we get is the area under this curve, or the area of the shaded region. That's getting the area by integration. So after getting the area enclosed by the line, we therefore find the area enclosed by the curve by integrating the curve equation. Now let us look at that one. Let us integrate the curve equation. Now the curve equation is given. We integrate from which limit? From 0 to 8. We integrate, that is 9x minus x squared dx. So when we integrate this, we say that the law of integration says we increase the power by 1, we divide by the new power. And therefore, if we have this 9x, we increase the power is 1. So we increase the power by 1, it becomes 2. So it is 9x squared. We divide by the new power, 2, minus x, increase the power by 1 cube over 3 plus c, constant must be there. Then we integrate from which limit? From 0 to 8. So the first one we replace with the 8, that is 9 into 8 squared over 2 minus 8 squared over 3 plus c. Then we subtract with the 9 into 0 squared over 2 minus 0 cubed over 3 plus the constant. Remember, when we multiply any number with a 0, we get a 0. And the constant c will cancel with the other c. So what remains here is 9 into 8 squared over 2 minus 8 squared over 3. So when we punch that on our calculators, we get that is 64 multiplied by 9 divided by 2 minus 64 divided by 8 minus, to calculate 64 divided by 3. So we get 266.667 square units. So we give units, we say square units, that area. If you get your answer is negative, you neglect the negative. The area cannot be negative. Now, after getting the area of the curve and the area of the line, you subtract the two areas to get the area enclosed or the area that is shaded. And that is, we now take 266.667 minus 32. So what do we get minus 32? We get 234.667 square units. That's how we do it, students. Square units. So this gives us the area enclosed by the curve. Up to that point, we are almost coming to the end of this integration lesson. Hope it has been interesting. Let us follow each step that we are required. The first very important is to know how to integrate. We say we increase the power. Integrate to make something great. So we increase power by 1. Power by 1. Then we say 2 is divide by new power. After dividing by new power, then add a constant. So up to that point, I wish you all the best. Thank you for listening to this lesson. Let us meet in our next lesson.